Уважаемые коллеги, я
Dear
представляю
colleagues,
наших спикеров в рамках этой сессии.
our speakers of the second session are Evgeny Kogan, Chief
Петербургского
Expert
МИАЦа,
of St.
Николай
Petersburg
Кречетов, региональный менеджер
MIAS,
Интерсистемс, Олег Стефанович Медведев,
Nikolai
заведующий
Krechitov,
кафедрой фармакологии
InterSystems,
МГУ,
Oleg
и Сергей
Medvedev,
Воинов,
Head of Department of
руководитель
the
направления
Moscow
Digital
State
Health Сколково.
University, and Sergey Voinov, Digital Health Skolkovo.
Евгений, вам слово.
Evgeny, the floor is yours.
Чуть-чуть ошиблись. Просьба открыть презентацию Евгения.
It's a different presentation, so please put Evgeny's presentation on the screen. Again, the wrong one.
Ура!
Добрый день, уважаемые коллеги.
Dear colleagues,
Большим удовольствием расскажу вам сегодня
it's my pleasure to tell you today
в городе создается
about how an integrated
интегрированная карта.
EMR is being created in St. Petersburg. I apologize to those who have heard about this, the same presentation about 2-3 months ago. But for those who have not, it will be very interesting and important because a city EMR
Центральное место, которое позволяет перейти на введение информации в электронной форме. Как говорил Ньютон, удается видеть дальше других, если стоишь на плечах гигантов. Мы полагаем, что мы стоим на таких плечах, а именно на международных стандартах и конкуренции. Это те вещи, которые, мы думаем, позволяют нам двигаться, может быть, в чем-то быстрее, но, по крайней мере, чем без этого. Коротко о медицинской системе Петербурга. Это 5 с небольшим миллионов жителей, примерно 30 тысяч врачей, 240 медицинских организаций муниципального подчинения, еще 42 федеральных учреждения на территории Петербурга и какое-то немеренное количество медицинских организаций частной собственности, немеренное в том смысле, что вот приведено количество имеющих лицензию, а сколько на самом деле из них работает, мы не знаем.
You see the number here that have a license, 3,659, but we do not know the exact numbers. But all these medical institutions treat patients, and the information they are dealing with have to be accessible to all. I would have singled out 3 periods in the process of creation of AMR. We started with the exchange of lab test data 2014-2016. For the last 2 years, we're dealing with EMR per se. It is called St. Petersburg EMR in this city. And starting from this year, we are creating a structured EMR. And I will tell you about the peculiarities of the latter. When back in 2014, we have come across the fact that the city's labs have lab information system, but they all use different languages. The developers came to us and said, we are tired of creating integration number 12, number 13, etc. We understood that we have to create a common space to exchange lab data. And we started with this because in order to place the medical doctor in front of the computer, we have to make it so that the computer will provide certain data for the medical doctor. It turned out that lab data were the easiest, but we were facing the choice of standard. Not characteristic for our country to have a choice, usually were dictated, especially in the field of medicine. The Ministry of Healthcare is the dictator, but in this case, we had to choose the standard. We, I mean St. Petersburg. And the version. At that time, Boyka was the most common. The third version existed, but as experts said, it was not very good. But the second version was available. And then Fire came onto stage. Some efforts were spent for this selection. We selected Fire for the reasons described on the slide, and we never never pitied this selection. It was very useful that it was open and accessible, and 80% of structures within Fire were standardized, so we had to spend time to standardize only the remaining 25%. So it worked. And the result, we had such a system. It is in operation now in between all the polyclinics and labs of the city. When the polyclinic provides referral, the lab receives a sample, then a referral, and sends the results back when the tests are finished. The results thus are available for the organization that has referred the patients and for the other stakeholders. It was a flagship project for St. Petersburg. The Minister of Healthcare came over to get acquainted with the results, and there's now an MOH project for 7 regions of Russia based on the same technology. 123 million tests were performed in St. Pete during the last year, and any patient who have gone through the lab tests in the polyclinic can find these results, this data in the Department of Healthcare of the city. We have created also a compendium of the lab tests. We have taken loin as basis, have added some tests that are performed in Russia but are not performed within loin. It is called Latenus now. And all the labs of the city are coded within this compendium. And thus we can see and build the dynamics of all the lab tests performed and see the results. You can see the tests performed in different labs, and you can see the results in dynamics. At stage 2, we started creating the St. Petersburg EMR, electronic medical record. The architecture of the systems is shown on the slide. There are 3 levels: federal, regional, and institutional. At the institutional level, you have medical information systems, MIS. There are 7 main ones within the city. And certainly our hosts are one of those 7. But there are some others. There are 7 major ones and some others. And at the city level, there's a city medical system with integrational profile, and all the IS of the city are integrated with it. As of today, the volume of data transfer to the city EMI is practically like this. We have medical records for each and every patient who has ever come to either polyclinic or hospital. We have information about at least half of cases of medical care provision. But for this case, we have not so many things. We have information on diagnosis, dates, medical doctors, and not that many information or documents that were filed within these medical institutions. As you see, 29 for outpatients and 22 for inpatients. Around 2/3 of all lab tests, including the lab tests performed in the clinics. And the worst situation is with imaging as of today. But half cases of medical care provision for the citizens of St. Petersburg means huge volumes of information, and this information is very important and very useful now for the succession of medical care provision. That's an example. A boy who was referred to an orthopedic clinic. When he was administered, he had a cough and running nose. Hence, the medical doctor has to prescribe something. If there's no integral medical history, the doctor might have prescribed something, but once he opens this integral medical history of the patient, he sees that this boy has some disease of the blood, and that's why he doesn't prescribe certain drugs. So the integral patient's medical history is an achievement of the previous year. The thing that is most welcoming in this integral medical history is the fact that we managed to accumulate the diagnoses and structure them in such a way that the doctors welcome them. Because, you know, the medical community doesn't welcome all the innovations. Any new form of presentation is not always welcomed by them, but this one was. Maybe because everybody is used to their ICD classes. So we have taken all the diagnoses, classified them based on their ICD classes, and everything was clear for them. We actually started with the idea that if before the reality was perceived by us by feelings, now it is perceived by applications. So this integral medical history became a kind of a navigator on the patient's AMR. When you click on a disease, and immediately the documents in connection with this disease are opened. But there is a gap here, to my opinion. We understand what a diagnosis is, but it seems that we do not understand well what is the difference between diagnosis and a disease. The patient will have a disease, but the diagnosis means how the doctor perceives this disease. And different medical doctors may perceive the disease differently, hence different diagnoses. So we have to accumulate the data based on the diseases, not diagnoses. This is maybe not exactly a gap, but a very flimsy area in our work. And maybe the doctors present here will help us move forward. And now let's imagine that we are successful in collecting the medical information. Starting from tomorrow, all the polyclinics, all the hospitals will pass over all the medical records to us. And we'll have such data like this one. It was a real story. It was a female, 73 years, and she visited polyclinics 242 times. Can you please click on the video? So if we look at her medical records, these are different documents that may be found in the record. So the doctor goes through everything, gets acquainted with the medical history of the patient, of this lady, goes on, and this happened in reality, mind you. So he goes on. And there's an option show the earlier docs. Certainly not, because it's difficult to cope with this number of documents. This is our future. That's what we're going to see when we create electronic medical records. We'll see a huge volume of electronic medical information. And this problem is not characteristic for Russia only. In May's issue of hymns, we see that in our EMR there are so many details. One of the authors or IT specialists of the hospital says that we even do not understand how to present this to the doctors. And our doctors are always making mistakes because we can't adequately organize this data. So what the next stage is? It is a structured EMR that will allow us to fish out at least something out of these different documents and present an archived version to the doctor, a compressed version. But we hear this expression many times, structured EMR. So what is it all about? It has to be produced. It is being produced in many medical institutions, but it is structured differently in each and every medical institution. So if we want to compile a common structured medical record, we have to make it the same in all these organizations. But I think this is impossible because I can't imagine how we'll be able to make all the doctors structure their thoughts in the same way. It seems to be a real problem of medical informatics. And we think to resolve it in the following way. We think to create a partially structured DMR. We, the medical community in this case, have to define the main parameters, start with them, and then these parameters will be assigned the status of obligatory ones for the doctors of certain specialties. For example, if there is a cardiologic patient and the doctor fills in a protocol of patient's exam, he has to fill in 25 parameters. All the other parameters will be voluntary, but 25 are a must, and they have to be the same for all the doctors. And the same has to be done for each and every medical specialty, and only then we'll be able to take all the information needed from the EMI in terms of cardiologic diseases, cardiovascular diseases, or other diseases. And thus we'll receive a register of diseases integrated into the EMR. Hence, the medical doctor will be able to have a review of the patient's diseases, which is quite problematic now, and will help the administrator to secure certain control over the patient's population. Why do we think that it is very important to base all our work on the standards? Because there are many questions that come onto stage when we do this work. Successity of treatment, CCDA, how to support decision making, CDS hook, registration of therapy plans. There are certain resources, how to automate the control of the therapy quality, clinical quality language. Hence, St. Petersburg followed the way of developing standards in this way. And now a few words to those who are interested in the international medical informatics. Back in 2014, Gartner published such a review with 5 levels of benefits that medical information systems can bring. We know the 4 levels, but the 5th level said the mentor, with no detailed description on what it is all about. The only thing that was said that back in 2014 there were no systems of that kind in that time. To my opinion, no mentor has come onto stage. Instead of mentor, we have the integrator. And it seems that Generation 5, in accordance with Gartner, are the integrators, or the medical information systems that integrate in between each other and secure the interaction in between the medical doctors and between the doctors and the patient.
So this kind of integration could bring together human effort and the technology and provide an integration thereof. Thank you for your attention.
Какие есть вопросы? Вот я вижу.
Any questions?
Есть вопрос?
Yeah, I see a couple here.
Спасибо за доклад. Есть один маленький вопрос.
Hello, I have a small question.
Интегральный анамнез был
You said that medical history
Как вы это оценили? Какая была
in the electronic format was well received by the doctors.
некоторый обратный фидбэк от некоторого
Was
количества
it
врачей?
human feedback that you're building on, or do you have any surveys or statistics? Yes, it was mostly just personal feedback. What we do now is that when we deploy medical IT systems, more and more doctors see an electronic medical record. So the system should be able to support the exchange protocol. It is simple. From the point of view of IT infrastructure, but it takes some effort on behalf of the medical information system developers in order to support that. As far as I understand, Sparm has not supported this yet. I think they want take these data and show them in their interface. I don't mind if they do. I think it's also a good idea. What we see now is that more and more hospitals and clinics starting to deploy this opportunity in their systems. We try to talk to the doctors and hear back from them what was successful and what wasn't. So we ask, on what occasions did you look into that, and could you find this information? And this is such sessions when we meet with a lot of doctors who started to implement this, then it's very useful. Say, when it's a very elderly patient and they don't remember too much, then this is an example that they quote. Or when the patient is not very reliable in the data that they provide. I'd also like to remind you that you promised to explain us about different access strategies and different access profiles, if somebody asks. Yes, we have St. Petersburg law, because we don't have federal law yet, therefore St. Petersburg City Committee for Healthcare created a regulation for this field. Medical doctors, first, medical institution that the patient is associated with, third, another medical institution where the patient has received medical care, fourth, this is the organization that the patient has been referred to, and any institution to which the patient has given access to this information. Now that we're launching the interface for the patient to decide that I give access to this and that doctor. So far we only gave access, it's a yes or no kind of decision. If you give access, then all your information will be accessible to the person you give access to. We short of time, therefore. Please remind them to use the mic, because we cannot translate unless they use the microphone. So the last part of the question. At the last conference of insurance in Germany, the insurers said that 7 to 10 days is too short for a standard stroke situation. Second classification for diseases, and then for functionality. And I think this classification gives you a way to describe the disease, what you call the problematic sphere. And the third classification is the classification of interventions. We don't discuss it that much, and every hospital finds their own way. So perhaps we should use international standards to answer these challenges and move to use international standards rather than choose between different standards that we encounter.
Следует, что я плохо выразился.
Well, I don't think
Все поняли.
I
Мы не собираемся создавать никаких
was able to get across. We're not planning to create any standards.
того пула
What
информации,
we want to do is to use the information that the doctors fill into the EMR. We want to highlight the more important ones. The doctors will still have to fill in everything,
о том, что
but
важно, а что нет.
we should discuss it with doctors and agree what is more important and what is less important. We've seen some success. We've seen some success in this dialogue already,
Эксперты в каждой
because in every field there are experts. There's Almazov Center for Cardiac Diseases, for instance, and there's trust in their expertise. If they
которые они считают необходимым.
rank us 20 indicators that we should track,
Кодируем это по СНОМЕДу.
then we will of course use the map to code those,
А это же не новые понятия.
because they won't be new.
Для полноты картины мы, конечно, это сделаем.
So we will
Но не в этом
include
содержание
that
работы.
coding,
Да,
but our
содержание работы в
work
том, чтобы выделить для каждой
will be
специальности 20
elsewhere.
вещей,
It will be to point out those 20 most important indicators to start with.
Потому что это уже достаточно узкая область становится.
We are discussing, I think,
Евгений,
some
спасибо
smaller
большое.
points, so
Видите, какая бурная дискуссия, сколько вопросов.
You could
Я приглашаю
continue afterwards.
Николая Кречетова.
Thank you very much. I think this was very interesting. You see how many questions we have. And now Nikolai Krechetov from Intersystems. Nikolai, the floor is yours. Hello, everyone. I'd like to share my personal story of how I got to know Intersystems as a platform. It was in 1993, and I was a student of Moscow Physics Institute. About same time of year, I was done with my exams, and one of my friends offered that I work for him for a month, because somebody was on holiday, and I was asked to develop this small feature for a large IT system that operates at Hotel Ukraina in Moscow. Some sort of monitoring tool that will allow to service the system, to check whether it's operating properly, and so on. So I was asked to do that, and how much time do I have for that? And he said, well, is a month okay? And I said, no, I'd rather not, because it doesn't sound right. Because I've never worked with your platform. I used Clipper, Fox Pro, Assembler, and C as programming languages. And that platform was completely foreign to me. But that friend of mine said that this is the system that was developed in American healthcare, and now it's used everywhere else. So perhaps you could read the manual and do it. So I did that. I was studying the subject for 2 weeks, and 2 weeks for coding. I got paid, got accepted, so I went on to take my holiday at the Black Sea. A lot of time has passed since, and if they asked me back then about the criteria and philosophy behind the platform for medical information, then I think I would name those 4 pillars: that everything will have to be integrated or interoperable, that the system will have to be reliable, as intuitive as possible, and that it can scale from 1 user to millions of users. What is the market situation now, and what are the current requirements that are out there? I think there are three main drivers that determine the features and the opportunities of medical information systems. There's a ton of different players, medical centers, various actors, including the patient, him or herself. We see the information volume grow by order continuously, and those who develop medical information systems are always stressed because new technologies for interface development come up every day. New treatment tools, new medical devices come up every week. Business situation changes. Therefore, the whole system is under a stress, and therefore, what you call in English a pervasive disruption, when an ecosystem is continuously stressed and shaken and everybody's tense. So I think that these challenges can be boiled down to three ones that I list on this slide. And in order for the system to be decentralized, the system must be able to aggregate, disperse clinical information from any source and bring it together. It should be able to use state-of-the-art technology, machine learning and AR to mine and track and find information that will be relevant and that should be available at the right time in the right place. This would be able to free the time of the developer because the system should operate on these principles today and in 10 years. We've been on this market for 40 years already, and we are part of every element of the medical information ecosystem. From hospitals such as Nikiforov Center, we partners with medical apps development such as SP.ARM. We work with researchers, people who work in biotechnology, who create medical equipment. As of today, worldwide, we have 500 million ERMs worldwide that are operated on various medical information systems. Today, I would like to present a platform, InterSystems Iris for Health. This is our foundation platform, which we use to test all the requirements the developers have for such a system. We also do development based on InterSystems for Iris for Health of a more applied solutions, say BookMS, which is now called TrackCare, is one of the products that was based originally on this platform, although it's not used in Russia for a number of years. HealthShare is another product which allows for medical information exchange between clinics, between regions, between countries. And there's a number of solutions provided by our partners which respond to more specific challenges. So it's a multi-layer business scheme which allows us to cover, I think, every subfield that needs to be covered, because we have a medical information system of our own making. Therefore, we're very well familiar with what clinics want, especially if they want HIMSS certification. We have seven hospitals who have achieved HIMSS certification level 7 with the use of our track care solution, mostly in the Near East. Our platform has been evolving for quite some time. It started as a platform for managing electronic medical records back in the 70s, late 70s, early 80s. Then we added to that analytics, integration with other interfaces, and we're adding more and more. For instance, it was a hot topic in Helsinki last week where many people presented on the use of artificial intelligence and machine learning, and this is all connected to one platform, one product. If you do it on premises, and this can integrate in 5 minutes in the cloud, it's seamless, instant integration with all the information subsystems. I know that here we have representatives of businesses who try to provide innovation in medical information, big data and machine learning. So here various machine learning models can be deployed on our platform. Therefore, we invite your innovation and provide you a number of tools which are ready for your use. The core of our system is built on the standards such as FHIR and so on. This is all available out of the box. InterSystems philosophy, I think, didn't change much over the 25 years of our operation. I think these core pillars are still true 25 years later. And these 4 letters that comprise the name of our product, they ensure that we achieve maximum result with minimum effort on medical information systems market. Thanks for your attention. Thank you, Nikolai. Any questions?
Спасибо большое.
Thank you very much.
Следующий докладчик.
Let's hear then from the next presenter,
Олег Стефанович Медведев,
who is Oleg Medvedev
МГУ.
from Moscow State University.
Good afternoon, dear colleagues. Great thanks first and foremost for the organizational committee for this invitation. I am from St. Petersburg initially. At some point I've relocated to Moscow, so it's even more pleasant for me to come back to my native city. It was mentioned today for many times, the artificial intellect. The organizers of our fundamental medicine department at the Medical State University and Cardiology Center personnel addressed me to tell them what it is all about, the artificial intellect for medical doctors, because the doctors practically cannot read special literature on programming, on maths. So I will allow myself to express a medical point of view, how the medical community sees all these innovations. One of my favorite authors, Eric Topol, who is a cardiologist, a geneticist, and the director of an institution, and also chief medical advisor of Medscape, a very popular website, medical website. So his recent book that came out a month ago is called Deep Medicine, How Artificial Intelligence Can Change Medicine. On the right here, you see a quote by Sundar Pichai, the CEO of Google. He thinks that AI is maybe the most important thing that humanity has ever worked upon. To his opinion, it is more important than electricity or fire. Some fundamental, principally new thing, principally novel thing. And we can remember what our leaders said as of lately, not maybe specifically in terms of medicine, but about the global impact of AI. There is an understanding about the 4 stages of industrial revolutions. The first one is when the engines and steam engines, the trains, steam locomotives came to life. The second half of the 18th century. Second stage is mass production, assembly lines, electricity. Number 3, stage number 3 is electronics and computers, PCs. And the fourth industrial revolution, according to many authors, is the artificial intelligence. And these authors also think that medicine is somewhere here right now, not fully understanding all the possibilities of AI. Once again, what the medical community sees and how they understand the AI. Machine learning, robotics, expert systems development, natural language processing, deep learning, and traditional machine learning. And mind you, this is an article, a publication from the Journal of Ophthalmology, not the computer journal. So all the advanced doctors are trying to make head or tail in terms of what's to be done with AI in medicine. To my opinion, the main thing we have to understand is that when the algorithms that really may be called AI product, it means the use of big data, large arrays of data. And the main sources for these databases are the constant flow of data from various wearable sensors that include physiological and biochemical parameters from each and every patient. This ongoing monitoring. But there's such a lot of data like this that even though the costs of hard disk space go down, it is very difficult to identify the trends. The second group are the high-resolution images and scans, MRI, CT, PET, X-ray. We are working now together with the CERN and our International Institute of Nuclear Studies in terms of using new sensors for MRI, for CT, that would allow us to have colored scans. They use semiconductor detectors that perceive directly the X-ray radiation with the evaluation of several levels of energy. And working with such a detector, we have an opportunity to automatically single out different tissues based on their contents, whether it's bone tissue or fat tissue, etc. And immediately they will be colored differently, and the researchers will see them in different colors. So together with Dubna and CERN, we create a joint lab based at the Moscow State University, where the computer tomographers of this new type will be installed, and high-intensive MRI, 7 Tesla. So we'll be using these two technologies, and the main goal is to learn how to get such scans, and the resolution there is around 50 microns, and very soon we hope to get 15 to 20 microns, which will give us a very high level of detailization that was unavailable before. And number 3 are the database of genome sequences, a very actively developing area that is becoming cheaper and cheaper with every month and every week. Hence, the scope, the volume of this data will be on the growth. And that's what we have based on the previous years and future years. How the wearable sensors are planned to be used. The sensors that register physiological and biochemical parameters. We assume that the number of sensors in blue are of medical use, will grow, but not as actively as the sensors of mass use. We may call them fitness sensors. It's a different system of registration, a simplified one. And we may receive the information from these sensors as well, though the accuracy of their measurement is not as high as the accuracy of the well-certified sensors. We have well-known companies in our country that are developing the platforms that unite these sensors. One of them is SP.ARM. Maybe you even heard about them. It's a group of developers from St. Petersburg initially, and now they have very good positions on a global level in US, Switzerland, Germany, etc. A well-known company, and their main achievements are as follows. Practically all the monitors, all the wearable sensors that exist in the world, they've developed the communication system with them, how the data may be transferred to the mobile phone, and this allows to integrate these sensors into your programs, never mind the manufacturer of the sensors. Unfortunately, in Russia, this is not well developed, though the team of developers is from Russia, but these technologies are mainly used abroad. Why so? Because our system of medical devices registration is very long-standing and quite expensive. That's why the life cycle of the majority of monitors is comparable to the time of registration. By the time we register finally the sensor in Russia, it is high time to switch the sensor to a new generation because its life cycle is practically over. FDA has a much shorter period of registration, and since our authorities do not think about switching to a different system of registration, we are lagging behind. How AI is being used within the framework of this monitoring. You see two ECG monitors on the left. LifeCore is the manufacturer. And these are tiny devices for one-channel ECG registration. A small one is in the watch, and they are registered by FDA CE mark. These are medical devices for ECG registration. Very convenient, very beautiful. Unfortunately, it has not yet been registered in Russia. Why this small company is famous? They managed to outwin Apple in this fight because Apple has produced Apple Watch 4.0 that also allows to register ECG when you touch the button. But a LifeCore is well known for the fact that they've understood the necessity to intellectually process the primary information, and they have come into consensus and alliance with Mayo Clinic. And Mayo Clinic provided access to 2.5 million ECGs to them. They have carried out the trials and have developed algorithms for automatic verification of the atrial fibrillation, which is one of the types of arrhythmias which is very prevalent, up to 10% among people advanced in age. They have processed the data and 4.3 million measurements of the level of potassium, which is very important for the patients with any types of arrhythmias. Based on ECG, with the accuracy up to 1%, they can define the level of potassium concentration in blood. So you register ECG, and this algorithm will allow you to define the potassium level in blood without additional medical tests. This is a great achievement, which Apple could not achieve. And this is another proof that you don't have to be really huge to make a breakthrough in this area of AI. It is clear, and we all know this, that patients and ordinary people do not like to wear these toys for a long time. This may irritate people. So in the near future, I think there will be detectors for remote registration of physiological information, like Doppler bioradars, broadband ones, color detectors of the color, skin color changes, the impulse wave of the blood, arterial blood, which is more scarlet, and thus gives a change to the skin. Without any wearable sensors, you may detect any changes. That's how these things are really used. United States patent, you see, as one of the examples. That's how such sensors may be used. You see, the sensor is integrated into the mirror. Lady comes into the bathroom, and the main physiological parameters are registered with the help of the mirror. There are many systems like this as of today. On the right, you may see a device developed by an Israeli company, and it is commercialized on the market. It can divide heart rate remotely, blood oxygen saturation, etc. The baby is lying in a cot without any sensors, but the information is being collected. That's where we're moving to. Certainly, the huge market that is not yet covered are our population, healthy people. We talked about the patients and the hospitals. This is great. We're thinking about our patients. But until you have stepped over the threshold of the hospital, you are a healthy citizen, and this group, this population, has to be covered as well. Because when we think about these people, we have to speak about early diagnostics. This slide shows that in accordance with the recent data, you see General American Association shows JAMA that the dietary risk is a main risk factor for the development of various diseases. Only after the dietary risks we see tobacco, high blood pressure, etc. Hence, there are opportunities when we can devise such things anew. Around 2 months ago, such devices came onto stage. We managed to get one. This is a very small device to measure hydrogen in the exhaled air. You know microgenome and how it impacts the health of human beings. Everybody is speaking about consuming more fibers, but I think each and every person has to have this device, the same as blood pressure measurement device. Because you exhale, you measure the level of hydrogen, and in accordance with this hydrogen level, you change your diet. These are the recent offers in terms of personalized nutrition using various technologies, registration of various physical activities, types of behavior, etc., that allow us to evaluate many things, but not very effectively. Biomarkers in the blood, everything that is being generated by microbiota. Genetics is not that applicable for mass consumers because it is quite expensive. You can't install sequencing devices. For example, a sequenator in Ocean or in the hypermarket Tvoj Dom or your house. While microbiome sequenator seems to be more realistic and more possible. So I draw your attention to healthy population and the necessity to use our information opportunities to record this data. And that's what we have on the market right now, and that's what can be used. We see how this device is being used. Various test loads, food loads may be used. And based on this, we may recommend on an individual basis to this person what he has to eat, what not. Very important things are happening in terms of scans and images analysis. The classical works from the Toronto University were crucial in terms of developing the algorithms for the scans analysis. Hence, the quality of images and works from 2012 went up. New York Times, as of 16th April 2019, what did they do? From the city cams that monitor the New York Central Park, you see on the left an image of a very low quality, but that's sufficient to identify this person. It turned out to be a person working at SUNY University. So if we activate our mobile phone, it's just a confirmation of the fact that this technology is working quite reliably. Another company, Face2Gene, who is using videos of babies to diagnose genetic diseases. And they use this quite broadly already. These are classical works, AI in radiology. More and more works appear where the authors state that the results of these devices are better than for radiologists who examine the scans. FDA, a very strict body, has permitted to use a device based on artificial intelligence that allow to define and detect the disease. This is a video cam and the program on the cloud server with the algorithm that processes this data. They define diabetic retinopathy, which is a step towards diabetic blindness. So they provide an answer either yes or no. If not, then the examination is recommended after 12 months.
So, of course, we will not end in a situation where the whole of medicine operates differently, but for specific diseases we will achieve important progress. This is the evaluation of human errors in image evaluation and in natural speech perception. Yes, I'm about to finish. This is also now used to control false reports of bank robbery in Spanish police. Now they can detect it with 97% accuracy. A number of companies use these solutions for medical decisions. There are huge also systems to collect this type of data. The UK wants to collect genetic data of 5 million Britons in 5 years. American All of Us research program does this, works with 1 million Americans, and there's a Chinese program as well. Russian developers are very familiar. Enormous Analytics study shows that Russian players in Eastern Europe are an important segment and provide about a quarter of all new developments. People like Alex Zhavoronkov and so on. These publications come in best journals. You see people from the New York University, leading Russian institutions, University of Oxford, and so on. So this is an example of high-quality international research based on big data. My personal view on this is that operating capacity, processing capacity, algorithms or software, whatever you call it, and medical bill data are the three key components to our success. The Chinese and the Americans have already overtaken us in the race for supercomputer development, but the biggest issue is that we don't have enough standardized and structured, verified medical big data. We're just working out the standards for this data, and algorithms can only be built on that. Therefore, in my opinion, is that we should use international standards, and this will allow us to leverage our strengths, integrate with international healthcare in order to use big data together to our shared advantage. Thank you.
Алекс Стефанович, спасибо большое. Вопрос.
Thank you very much. We don't have time for questions, unfortunately. I'll have to invite the next presenter now, Mr. Sergey Voronov, who is leading digital health at Skolkovo Foundation. Good afternoon, dear colleagues. Thanks to SP.ARM for inviting me to take part in this. It's also very lucky that I am presenting after Oleg Medvedev, because he has set the bar and he described a type of projects which could be implemented in Russia. The projects he described, they have a big R&D component in them, but are commercially viable. So this criteria is what Skolkovo Foundation looks for in projects, and what we try to support. Projects that bridge research and commercial use as a startup. Any of the object that Oleg has demonstrated in his presentation there, its manufacturers could have been a resident at Skolkovo. I also saw a number of Skolkovo residents already there. Med-M, for instance, has been our resident for a while. Sotsmedica, they do systems for prescriptions, and I saw that they use their architecture in the presentation of our colleagues from the Nikiforov Center. It's very nice to see how our small resident companies penetrate the market, take part in large commercially successful precedents. Therefore, this means I believe that our approach to building ecosystem is right and we're on track. We don't have that much time, therefore I would like to briefly describe our opportunities, what Skolkovo Foundation is. Skolkovo is first and foremost a place which is organized around the innovation. In a way, it's a city where there is a tech school, where there is foundation, we have a school as well. So I believe that we want to create an environment in which innovation development will be a continuous process, that they can start at school level, that at university level some of the smaller projects can spin off, and also once they reach company size and become startups, then they come to Skolkovo for support. This is not just financial support, although we have that, we have also investors contacts, we have mentorships, but it's also the streamlining of processes and facilitation in every aspect, support of our ecosystem and from mentors. We have about 80 startups that work in the digital or digitized healthcare. SP.ARM work on more traditional projects such as medical information systems. They also need ways to innovate, and we believe that this kind of solutions will become a forge of new innovative projects because all the developments are based around data, automation of processes at healthcare centers, and I believe that MIS create the framework within which new innovative products can come up from places like Skolkovo. You discussed machine learning and AI a lot today. This is undoubtedly the vector for the future, and Russian developers are well positioned. Although we do lag behind in terms of standard development, but we have something which is more valuable, because standards is easy to adopt. You can take international ones, or you can quickly develop national ones. Now we see that there is a will to do so in Russia, but what we do have is enough healthcare professionals. We have strong mathematical education in this country, and if you look at a couple of our residents, for instance, such as Botkin IM or the Третье мнение, Third Opinion, who could, after raising small investment, have been able to achieve results comparable to companies who received much more investment, because they didn't need to, they could cut costs in terms of AI training, and we, I think, still have the lead in this respect. It's just a matter of giving support to this, creating databases for medical images and medical data, creation of standards and harmonization with international organizations. Once we've done that, we can end up with a genuine technological leader that will be a Russian company. Why do we need a foundation in this ecosystem? Well, because we are here as a breeding ground for such leaders. Here we have a number of figures about what kind of benefits Skolkovo residents have. You can pick up the copy of this presentation and study this in detail, not much secret there. This is all open information. We have grant support, and one of the ideas behind the grant allocation process is that the that the investors' risks in R&D projects are hedged. We don't just allocate funds to support science. There are other institutions who do that. We cooperate with external investors, such as venture investors, in order to facilitate their investment into challenging, complex projects where it's tough for investors to understand whether these projects are feasible or not. It's therefore our mission to support such projects. We also want to stimulate the arrival of venture investors to the Russian market through our activities. Our ecosystem works with both startups and corporate clients. They can be state-owned corporations, this can be medical clinics or networks of hospitals. And sometimes they need us to provide expertise that will enable them to find solutions to problems they have currently, such as non-standard issues, not selecting a vendor, for instance, but rather how to pick up the right team that will do their machine learning or image recognition or VR. AI is discussed a lot today, but there's already a number of use cases for VR and AR in healthcare. So we have clients who come with such interests, and we have a process in place that we have acceleration directors, over 700 external experts who check the technological state of our companies, and we can also assemble an expert pool for you in order to evaluate this or that innovation. Somebody from Doc Plus has already been speaking. Me is also here, but because ecosystem is pretty tight and everybody is aware of any interesting conference or event, therefore we're all here today. So these three bubbles exemplify companies that work in IT, biomedicine, and in the area where IT meets medicine. We work a lot with drug development. IT cluster mostly works with usage of IT in medicine, such as trackers, fitness devices, gadgets. We learned from our experience in this field that good startups are likely to be born by doctors rather than IT specialists. So critically important is to have medical expertise for a startup rather than any other type of expertise, because people who only work with IT and think that they see a medical issue, then when they start to speak to doctors in the real world, they encounter a number of unexpected difficulties. Therefore, we really welcome that innovations come from the clinics, so that the doctors themselves come up with their projects, come talk to us at the foundation, and we think about IT solutions that could facilitate the tasks that they have to work with and support them in their undertakings and in their innovative endeavors. Artificial intelligence is something that is at the front of the news recently. Many of our companies were there at HIMSS exhibition in Helsinki. Thanks a lot for that to the organizers, Harold in particular, because this has shown how our part of ecosystem fits into the international landscape, and we hope that our partnership will facilitate the access from our Russian startups to the global market and be on the level with the best practices that exist globally. With that, I would like to thank you for your attention. Thank you very
Спасибо
much.
большое.
Thank you, Sergey.
Спасибо. Коллеги, мы сейчас переходим к панельной
Now
дискуссии.
we
Небольшая
will
завершающая
open the
панельная
floor
дискуссия, где мы
to a
сможем
general
обсудить
Q&A.
несколько вопросов,
There will be a
После этого мы
small
переходим
panel
уже
discussion
к
as well,
фуршету и общению в кулуарах.
and then
Виктор
there will
Иванович,
be a reception.